Would you like to learn about generative AI architecture, specifically in the realm of databases and training data? If so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers. I've been an IT architect now for over 25 years, and I've been helping others get their first tech job for more than 2 decades. I am joined by David Linthicum. David is an expert on cloud architectures, AI architectures, and generative AI. And today he's going to be talking about generative AI architectures with us. David, would you like to say hello?
Yeah, Mike, hello. It's great to be here and to discuss one of my favorite topics, how to build successful generative AI systems and get it right in an optimized state the first time, which is a very desired skill right now.
Yeah, I'm with you, David. The demand for AI architects or AI professionals in general is huge right now. And, I truly believe generative AI and AI in general is the next disruptive technology. Since that internet boom, when I started and I was helping to build out all these networks, which made all of these things possible, generative AI is the next thing that I've seen so much corporate excitement about.
Yeah, it's really a game changer. You think about it, we're finally able to take the concentration of data we've been gathering over the last 30 years and then make common sense of it in ways that we can weaponize it to make a better business. So we can have systems that are able to make decisions, optimize supply chains, really kind of create what I call innovative differentiators for businesses where they're able to build a business around these systems that are able to do things in a much more advanced way, in a much more efficient way. And I think that's ultimately, what it's all about. So it's not only just the automation of something, which was really what I'm working toward for the last 30 years. It's about the ability to leverage information technology as a true force multiplier for the business. In essence, it becomes the business.
And I'm with you. Technology in general does become the business, and organizations who leverage technology the right way have extreme business advancement over their competitors. And organizations that just adopt it in a willy-nilly approach, the tech may work, but I think they actually hurt their business in many cases.
Yeah, they do. There's been a bunch of under-optimized architectures, whether it's cloud architecture, IT architecture, things like that, that have started to appear on the scenes in many organizations. And I always get the feedback. Well, it works. Okay, it works, but it's costing you 10 times as much. It's under optimized for the needs of the business. It's not able to live up to the requirements of the business. And therefore, you're not doing your job as an architect, as an IT professional to rebuilding something that's optimized for the space. So we have to really get very detailed in how we focus these resources in the right way, how we deal with the data, how we deal with the inference engines, the processors, because let me tell you, generative AI systems and systems in general are extremely expensive, whether you build them on premises or in the cloud. And so we're going to have to figure out how to place our bets, probably a little bit more particular than we did in cloud, and a lot more particular than we did when we first started building some of these on-premises systems. So everybody is looking at this technology as a game changer, but not necessarily looking at the way to leverage it with the most effective path and the ability to kind of align it to the business. So we need people out there that are technologists, but also business people, the ability to align technology to create a configuration that's going to bring the most value back to the business. And believe it or not, that's what architects are supposed to do. They're supposed to bridge the technology between the technologist and the business, and align them together so they can have the most perfect sync and bring things forward. Organizations that are able to do that are going to be the ones who win and survive and are able to leverage technology and weaponize technology to take their business to the next level. Organizations that don't figure that out are going to be deprecated. They're going to be pushed to the back. They're going to end up being sold or buy or divested, things like that. So it's going to be a big shakeup, I think, for the next 5 to 10 years in terms of businesses leveraging technology, not just to automate stuff wasn't automated before, but the ability to leverage their information technologies as true force multiplier for the business.
Yeah, I'm with you. And it's all about mapping, the technology to a business challenge and optimizing the business. So let's talk a little bit about the generative AI architecture, specifically in the database and the training data realm. Could you explain that? Because, to me, if we have the wrong data, the generative AI is going to do everything wrong, garbage in, garbage out. But I know you know a lot more about this, so I'd love to hear your perspective.
Yeah, and I was at the Data Universe conference this week in New York, and actually talked about this. And the message is fairly simple. If you don't have your data in a good architectural state, you're not going to have a solid generative AI system. It learns from the information that comes into the system, and so if we have very dirty data, it's incorrect. It doesn't live up to current data hygiene. It doesn't have standards built in, things like that. We're not going to be able to leverage it as training data to take the generative AI system to a level where it's able to solve problems for us. And people forget that. And so they have these abysmally designed databases and data all over the place. They don't have a single source of truth. They don't have good data hygiene practices, don't have good metadata practices. And now they want to throw an AI system on it. And that's not going to work. So that's why I always tell people the hardest problem to solve with building generative AI systems is to get the data into a state where it's going to be valuable to the engines that are able to train from the data. And that's something that, quite frankly, it's not necessarily a fun task. You have to go through your DB2 tables. You have to go through your structured and unstructured data, your PDF files, your file farms, all kinds of Oracle, all kinds of object databases, all kinds of things that are all over the place in different heterogeneous formats, and put it into a logical order where it's going to have the ability to train these generative AI systems better. That doesn't mean, by the way, you have to upend your data and migrate it to a single data platform. That's not going to work either. But the ability to leverage data virtualization, data abstraction, good data security practices, your ability to apply standard metadata across the system. So when we point the generative AI system at it, we know that the data that's training the system is in good working order and in a good state, where we can make the engine as accurate as possible. It is garbage in, garbage out. You just hit the name on the game. You got to remember, generative AI is a version of machine learning. It uses unsupervised learning to continuously learn from data that's sitting in the back systems, and it's going to have it's going to have a relationship with that data ongoing, not just a ETL, extract translate load, but the ability to refresh itself and continue to talk to itself in different kind of methods and formats. And it's ultimately that becomes everything in terms of where the generative AI system is moving to. I think the thing that's lost on the technologists right now, everybody's focusing on processors, GPUs versus CPUs and TPUs, and I think that's going to be important. But really, the focus needs to be on storage, networking, and the ability to store lots of information, retrieve it in a very expeditious way, and the ability to kind of get it into the systems in its good format, ready to go. And so that means that we're leveraging good data design practices. We're doing, ERD modeling, and I teach this in the course. We're doing good database design. We're doing transactional systems. We're doing logical access management of the systems and how we're approaching the data. We're looking at this stuff where we're able to have a valid understanding of the information, where it's able to take the generative AI system to the next level. You give me a good database, Mike, I can build a solid generative AI system on top of it. You don't, you're going to have to fix the data first. This is not something where you bolt it on top and you hopefully that the AI engine is going to figure out where the erroneous data is. It won't. It's just going to become stupid, and it's not going to be able to solve your issues. And you just spend a lot of money and time in to build something that's not going to have as much value as it could have.
I really like what you talked about. Everybody is really worried about the compute. It goes into that speeds and feeds conversation we used to have in networking, and everybody was focused on how fast the routers could push packets, but they didn't think about the routing design, and everything would come crashing down because it didn't matter how powerful these devices were if they didn't have good routing information. And I think we're here because you're right, the focus is all on the compute. Nobody's talking about the data. No one's talking about cleaning the data, optimizing the data, normalizing data, mapping and reducing the data, so you don't have Mike Gibbs spelled 10 different ways. And that's just one example, let alone all the different data sources people have. So I think you've got a really great point there. We've got to fix the data. We've got to clean it up. Because without the good data, what are we going to get?
We're not. And you have to focus on the architecture of that as really the core value and the core starting point of any kind of AI system, specifically generative AI system. You have to remember that there's a multiplier in terms of bad data. Information that comes into a generative AI system, that it trains the data, will have an effect on the system and have irrelevant logic where you're not going to get as much value out of it. It's going to produce the wrong information. It's going to come up with hallucinations, inaccurate information, very much, like we had in bad business analytics. But in the AI world, in building these knowledge models, if they're trained with bad data, it's going to be very difficult to debug those systems. You're going to have to, you're going to have to basically throw it away and rebuild the system using correct and clean data, and that's not something you want to do. Rebuilding an AI a database, an LLM, is going to take sometimes many days, and cost many thousands of dollars in cloud usage or many thousands of dollars in on-premise database, on-premise systems. And we just can't do that. We can't keep reinventing and rebuilding these things, moving forward. So if we're going to take use of this thing, you got to understand there's certain disciplines that come along for the ride. The ability to deal with database design and database understanding. So in other words, you can't get into a generative AI architecture position unless you have a good understanding of database design and also some rudimentary understanding of data science as well. And your ability to pick the right weapons, pick the right data hygiene systems, pick the right data integration systems, pick the right data cleansing systems, all these things to put the data in a state that's going to be much better than it was currently. The good news is this has a systemic value beyond just the generative AI stuff. One of the big complaints that I have with enterprise architecture, and I'm sure you've seen this as well, is there's not as much focus on the data. They have a tendency just to kind of push it behind. In other words, we can get at the information they have. They don't have a good usage of the data. Just by the fact we can get customer information, transaction information, things like that, that's not necessarily a success. We need to be able to leverage the data for more strategic purposes, and the only way to do that is if we have clean data to make it happen. And so it allows us to finally get at fixing an existing problem that we've had probably systemically for the last 20 years, and it's killing a lot of the enterprises out there. And I think that fixing that problem not only adds value to the generative AI system, but also the inventory management system, the transactional system, and the ability to have things that perform better and stop providing erroneous data, the ability to have the website operate faster, the ability to get at the information that's going to provide a better customer experience with the different customers' touch points that you have. And so it has this systemic value that comes beyond some of the generative AI stuff. So when I make a case for fixing some of the back-end data systems and designing a better database and cleansing some of the data, it's not just for the generative AI stuff, that's just fine, but the ability to touch pretty much every system that touches data, which is most of them. They all touch data in some way, shape, or form, and the ability to have data in a much better state, have better performance, better accuracy, better content, better resiliency, all these sorts of things just really kind of make the IT infrastructure much healthier. And I think that that's a step in the right direction. And I think a lot of people are going to breathe a sigh of relief, because if I hear of any problem within enterprise architecture, it always tracks back to bad data. And it's something that they're unwilling to fix because of the cost and also the risk in doing that. So they just kick the can down the road. We can't do that anymore. Generative AI is here. You got to fix that one way or the other, and you're going to be much better off from doing it. And now's the time to do it. We have the tools. We have the know-how. I'll train you and teach you on how to do that stuff. You'll have a good understanding how you build and deploy and look at these databases. And I think that's going to be a step in the right direction, and be able to turn it over to the database engineers who will work for you, who will take this stuff to the next level, re-engineer the systems. Data scientists, again, reporting to you as the generative AI architect, the ability to kind of take those to the next level. It's hugely exciting to me, because I think we've been putting this off for a long time holistically as enterprises. We can't do it anymore.
Yeah, and you really bring up so many good points. Yes, we need all of this for the right generative AI architecture, all that clean data, all the good access to the data, but it's the rest of the business too. Sales can look at the data and be more efficient. Whether it's manufacturing or customer service, they're going to have good data and they can analyze it. And a lot of times, at least when you run a company, you get a sentiment, you get a feeling, but your data doesn't show you what you're thinking and you're feeling. And as Jeff Bezos said, if your sentiment and your data are wrong, you're probably not measuring the right thing. And by having better data, organizations will be able to check the data, see what they're measuring, and actually be able to impact every aspect of their business.
Yeah, you said it. It's just going to be your ability to invest $1 and get 10 back in dealing with the database. And it goes beyond the generative AI stuff. As it said, it's going to have value in every aspect that you do. And some enterprises are better than others, but the ability to have good standards, good data security practices, good data hygiene practices, all these sorts of things really kind of need to be built in the infrastructure. So Part of this is changing the culture. In a lot of enterprises that I've consulted with in the last 10 years, they accept the fact that their databases are dysfunctional and they learn to work around them. To me, that's not a viable answer. And I understand why they're doing that, because it's very expensive to get back there and fix some of the back end systems and update the databases and migrate the databases to different faster databases and different database models, things like that. But the reality is that if it's not done, it's just going to keep on costing more and more and more. Complexity is a huge issue with data right now. In other words, we build databases normally using different heterogeneous databases, and whatever the cool database was at the time is the one they leverage. So I always look at, databases as almost, rings in a tree. Have the DB2 era, the, Codicil era, you have the relational database era, lots of Oracle. Then you have the object database era, which is still going on. You have the MySQL, the NoSQL stuff, the ability to use high performance database and process database, special purpose databases, all these sorts of things. So when you go into an enterprise, it's not only the data structures that are dysfunctional, but the fact of the matter is that the complexity around the heterogeneity there is going to be a challenge. Now, I understand why they did it, because you're supposed to build your systems with whatever best of breed technology at the time, and that may be the best of breed technology. I would argue probably some decisions were made around the hype, but whatever. Now we have to figure out how to mediate the complexity. Before we get into a proper state, we're able to get it into the generative AI system. So mediating the complexity with databases, we have a couple of options. Number one, we can blow everything up and push everything to a single model on a single set of databases, which are going to be more homogeneous in general. That won't work. It's too expensive. You're going to blow everything up, or leverage data virtualization, data abstraction, data automation to make better sense of it, which is a much better solution. Because what we're doing, even though we have to fix the physical data on the back end, what we're saying is we're going to abstract that data and look at that data in any format, type, any meaning that we need to look at it at. And if there's changes that need to be made into the back end structures of the system, we do so in middleware. We don't do so with the physical databases on the back end. However, many organizations don't know how to leverage this technology effectively. That technology has been around for a long time. I wrote, it was in my EAI book, which is behind me. I wrote about in the 90s. And the reality is a much better, sustainable way, reliable way to fix some of the back-end database systems, but it requires another set of understanding and another set of knowledge. Now, bring that into the generative AI systems. So if we're able to put a data abstraction layer, a data virtualization layer on these back-end heterogeneous systems, which are extremely complex, your ability to mediate the complexity and your ability to put that data in the right state makes it prepared to leverage data, leveraged by the generative AI system as core training data. So the nice thing is, in some instances, we don't have to gut the back-end system. Sometimes you can't, companies aren't able to afford making that happen. So we're able to put middleware layers in between the back-end physical database, in this case, the generative AI system, to get at the information using the layers that we need. The beauty of that is the generative AI system needs additional data sources in different structures, things like that. We don't have to go change the back-end database. We're able to change the thing in virtual middleware between the physical databases and the generative AI system that consumes it. So your ability to kind of understand what those tricks are and those technologies exist. By the way, I don't want you to be down and dirty in learning how these things work, Informatica versus VMware, things like that. But I need you to understand that it exists, so we can create a logical mapping between the physical databases and the virtual database that we're leveraging for the system that ends up being consumed in the generative AI system. So it becomes kind of a single touch point within the environment that kicks off the health of all of these generative AI systems moving forward. What I don't want to see, and I think we're heading for this now, not a lot of people are going to be taking this course, or even taking your courses, and they're not going to get a solid understanding of how these things work and how everything's interrelated. And so they're just going to layer a generative AI system in there, hope for the best. It's going to train itself on cruddy data, and it's going to be a cruddy generative AI system. And they're going to spend a lot of money on something that's going to fail. Just like the initial implementations of cloud computing back in 2000 and 2011, 9 times out of 10, those things laid eggs. People didn't know how to leverage them. They weren't doing the architecture correctly. They were just feeling their way in the dark. In this world, that failure is going to be about 10 times as impactful. Not only is it going to be very expensive, but it's going to delay the adoption of this innovative technology. Is going to change the business. So we have to do it right the first time. And that's what I tell people all the time. What about generative AI? We can't do this iterative, get it wrong 10 times where we get it right once. We have to come out of the gate, just because the expense and risk in doing that, get it right the first time. Starting with the foundation of data is the right thing to do.
Yeah, this is one of those things we have to do right, because if the AI starts doing things on its own, it has to work correctly. There are some things you can learn by making mistakes, but you can't learn medicine by making mistakes, because people will die. You can't fly an airplane by making mistakes, because the plane will crash. And if we're going to have AI doing things that people used to do, we have to get it right the first time, because we obviously don't want those negative consequences. David, I really want to thank you for sharing your thoughts, specifically on generative AI architecture in the world of databases and training data. If you're out there and you desire to become a artificial intelligence architect or an enterprise architect or a cloud architect, we have free webinars where you can come and join us. We'll talk about the entire career, and we'll answer any questions you have or help you in your goal to get to your ultimate architect career. If you've enjoyed this video, please give it a like, and please subscribe to the channel and hit the bell to be notified of new videos to help you with your AI architect career, your cloud architect career, or your enterprise architect career. I look forward to seeing you soon. Take care, everyone.